Okay, so in an earlier video, we talked about consumer surplus. We talked about producer surplus. Now we're going to talk about total surplus, which you can read right here, occurs at a specific quantity that makes D of Q, which remember is your demand, equal S of Q, which is your supply. So total surplus happens when the demand equals the supply. This is also called equilibrium, right? When the quantity that we consumers demand matches the quantity the producers are going to provide for us, everybody's happy, right? The producers get to make their stuff and sell it. We get to have all that we want to buy. Everybody's happy. So total surplus happens when equilibrium happens, is how this works. And down here I have a picture. I have this blue demand curve that was decreasing. I have this red supply curve that was increasing, and this place where they cross, this is my equilibrium point. It's where the supply equals the demand. And the total surplus is the area between the demand and supply curve. Ooh, that's supposed to say curve. Okay, so this kind of curvy triangular thing right here, this is your total surplus. Okay, so we're going to do a couple of things with this. We're going to find this equilibrium point. We're going to find the price maybe that matches that quantity, the equilibrium quantity, and then we're going to find this total surplus. So let's take a look. We have a demand function for metal thermoses. This is the demand one. And the supply function is this guy. Q is measured in thousands, so the first thing says what price should the thermoses sell for in order to maximize the total surplus, and what is the total surplus. So the first thing we probably need to do, the price that we should sell to maximize the total surplus is going to be the price at equilibrium. So first we need to find the Q, the quantity that makes equilibrium happen. So to do that, we're going to make the demand equal the supply function. So we're going to do 14e to the negative 0.15 Q equals 2e to the 0.12 Q. I'm going to divide by 2. So now I have 7e to the negative 0.15 Q equals e to the 0.12 Q. Okay. And now what I'm going to do is I'm going to multiply both sides of my equation by e to the positive 0.15 Q. So that's all still the same. And the reason that I did that is because now these guys go away. Because remember, when your bases are the same, you add the exponents. My base is e. If I add the exponents, I get 0. And e to the 0 is 1. So this side is just 7. And then this side is e to the point, add those exponents together, 0.27 Q. Okay. So now I'm trying to solve for Q. You can get rid of an E by doing a natural log. So I'm going to natural log both sides. So I'll have natural log 7 equals natural log e to the 0.27q, which means natural log 7 equals 0.27q, and then just divide. So natural log of 7 divided by 0.27 is going to be my q. I'm going to type that in my calculator real quick. And that is 7.2, we'll round to 1. So this is the quantity I should sell to make equilibrium happen. And this will also be the place where the maximum total surplus happens. So up here in the problem, what price should the thermoses sell for in order to maximize the total surplus? Well, the equilibrium is that 7.21. The maximum total surplus is going to be what we get when we use that quantity. So to find the price, I'm just going to pick one of our equations. I'm probably going to pick the supply one just because it's smaller numbers. And we're going to plug in that Q, and that will give us the price for the total surplus. So I'm going to pick the supply function to plug this in for. You will get the same number if you pick the demand function. So I'm going to do my supply of 7.21 equals, it was 2 e to the 0.12, and then Q is 7.21. And when you type that in, you get like 4.75. So this company should sell their thermoses for $4.75. And then the last thing we need to do, so we found equilibrium, we found this is the price. That will maximize total surplus. What is happening? Hold on, people. Okay. Anyway. Now we actually have to find the total surplus. And we're going to do this because we're going to do this with an integral, because remember back on this page, we said the total surplus is the area between, which means an integral. So we're going to do the area between. So we're going to go from 0 to, and then remember when we did our other surpluses, consumer and producer, we used the quantity. We're going to use our equilibrium quantity, which is that 7.21. And then when you do areas between curves, you do the top minus the bottom. The demand was on top, so 14 e to the negative 0.15 q minus, and then the supply curve was on the bottom. That was the 2 e to the 0.12 q. You can type that in your fancy calculator, and it will tell you the total surplus. And when you do that, you get 38.76, and remember this is in thousands, so in dollars this is really 38,706. Hold on, 760, and then the next decimal is $0.5. So just to recap, we have two equations, supply, demand. We want to maximize the total surplus. which means we need to find equilibrium. So we set them equal, we solved for Q. So that 7.21 is the quantity when equilibrium happens. And then we plug that quantity in one of our equations. We got 4.75, that is the price that will maximize the total surplus. And then we actually found the total surplus. When we did that, we did an integral from 0 to the equilibrium quantity. We did the demand minus the supply.